What's up, everybody? This is problem number 3 from the chapter 8 for response. So on all of these problems, you have to draw a picture and you have to set up a free body diagram every single time, even if you think you know what you're doing. All right, so let's first draw a picture. We've got a turntable, so we'll get a little circle in here. And on this turntable, we have a radius of 15 centimeters. So I'm going to convert that to meters just right off the bat, 0.15 meters. The coin is 5 grams, which 5 grams is 0.005 kilograms. And this thing is rotating at 60 RPMs. So 60 RPMs, that means we're rotating in this direction here. We're rotating in the counterclockwise direction. And let's draw a free body diagram here. So let's imagine that I've got my z-axis here, and here's my radial axis, which means that my tangential axis is coming out of the screen. Here's z, here's radial. So when this coin is on the turntable, it has force of gravity down, normal force up, and the force that is pointed towards the center, the radial force, the centripetal force here, is the force of static friction. All right, so that static friction isn't pointed in the tangential direction. It is pointed towards the center because that is the force. That is where the change of direction for this coin is. And so we have to have a force pointed in that direction, and in this case, it's the static friction. So let's write some equations. Sum of the forces in the z direction. Now we know the sum of the forces in the z direction for uniform circular motion is 0. All right. So the forces in the z direction here are the normal force, which is equal to mg. In the radial direction, then, I've got the force of static friction, which is equal to m times the acceleration in the radial direction, which is just mv squared over r. All right. So I've got all this information. Now let's start to substitute some things in. So in the radial direction, static friction is coefficient of static friction times the normal force, which is equal to mv squared over r. So I've got an expression for normal force right here. Let's sub it in. So mu static friction times mg is equal to mv squared over r. And the m's cancel out, so I'm left with mu s times g is equal to v squared over r. Now, at this point, we haven't really been looking for anything specific. We're just kind of trying things. So now let's go back to the problem and figure out exactly what it is we need to do. So the question is, does the coin slide off when it is rotating at 60 RPMs? Does it slide off? All right. So looking at the expression that I have right here, the thing that we're going to pay attention to is we're going to pay attention to this tangential speed, v, because we need to know what is the maximum rate this turntable can go for the coin to not slide off. All right? So what we're going to do with this is we're going to take it, we're going to rearrange it, and we're going to solve for v. So come over here. We're going to have mu s times g is equal to v squared over r, which means r times mu s times g square root is equal to v. Well, I know r, I know mu s, and I know g. If I come back over here, I've got r is 0.15, mu s is 0.8, and mass and g is 9.8. So 0.15 times 0.8 times 9.8 square root. I get that v is going to be equal to, oh boy, where's my calculator? Pause real quick. 0.15 times 0.8 times 9.8 square root. 1.08 meters per second. All right. Now notice that does not really help us compare to the turntable. The turntable is 60 RPMs. So let's convert 1.08 meters per second to RPMs. 1.8 meters per 1 second to revolutions per minute. All right. So let's start with just getting into minutes because that's easy. I've got 60 seconds in 1 minute. So seconds cancels out. Now, meters into revolutions. Well, we got to think, how long, what is the distance of one revolution? Well, the distance of one revolution is the circumference of the circle. The circumference of the circle is 2 pi r meters, and that's one revolution. So if I calculate that out, what I end up getting is that the number of revolutions here is 69 RPMs. Now this represents the max speed to not slide off. All right, so let's compare that to what we were given. We were given 60 RPMs. It's saying 69 is the max, so we are under that threshold, so we will not slide off. All right.